Okay, so in the last class, I have told you the eye defect myopia. And what is myopia? Defect of vision in which a person cannot see the distant object clearly, but he or she is able to see the nearby object clearly. Okay. So in myopia, what happens? Far point becomes less than infinity. Far point of eye becomes less than infinity. What are the reasons of myopia? Due to high converging power, due to eyeball too long, or you can say due to eyeball too large. These are the reasons. Okay, these are the reasons of myopia, and we have discussed uh, the cause and the correction. Okay, in the last class. Okay. And I have told you what is the far point, what is the near point. Okay.
Yes, sir.
Okay, so there is one more point that I want to write. Calculation of power. And I have told you that we use concave lens to correct the myopia. See here, this is the concave lens now. We use concave lens to correct myopia. What is the work of this concave lens? What is the work of this concave lens? This concave lens forms the virtual image of the object here, so that finally the image formed at retina and the person is able to see the image clearly. Okay. So calculation of power. Calculation of power. See how we will calculate the power of a lens to correct myopia. And in myopia, what type of lens we use? Concave lens. So basically, uh, power of the concave lens we will use. For example, suppose this is my uh, spectacle. This is my spectacle, and these have lenses also. So these lens have some specific power also. Okay, and these powers is calculated somehow. Different persons have different power. Okay, for their eye. Okay, so calculation of power of concave lens to correct myopia. Write the heading calculation of power of concave lens. Why I am saying concave lens, not convex? Because we use concave lens to correct myopia. Concave lens to correct myopia. Okay, correct myopia. This formula I think you should know. 1 by V minus 1 by U is equal to 1 by F. This formula, Martin, no? Do you know this formula? 1 by V minus 1 by U, 1 by F. And this formula, power is equal to 1 upon focal length in meter. At least these formulas you should know. Hamna, hello, are you in class?
Yes, sir.
So beta, do you know these formulas?
Yes, sir.
Okay. So basically na, how you will calculate the power? What is myopia? Myopia is something due to which the person is not able to see a distant object, an object which is very far, which is far from the person. Suppose I am having a myopia, suppose, and I want to see that very distant object, and I am trying to see that object, but I am not able to see the object. But object is at that position. So object distance, to calculate the power, you will take infinity. Why we are taking the object distance infinity? Because in actual the object is far from us. We want to see that far object. Okay, we want to see that far object. Okay, so object distance will be infinity. Infinity. Image distance, where image forms, see here, image is formed, this is the image distance. Image is formed at the, hello Subhana, okay, so image is formed at the far point of the person. Okay, so basically what should be the far point of the, hello Subhana, hello Subhana, so we are just calculating the power, okay Subhana, for the, for correcting the myopia. So now, what is the far point for a normal person? Infinity. But far point for a myopic eye becomes less than infinity. And what is the work of this lens? This lens forms the image of the object at the far point of the object. So basically what you will do, what you will do, image distance, in this case you will take the far point of the person. Why you are taking the far point of the person? Because image is formed at the far point for correcting the myopia when we place a concave lens. So on the basis of this, there is one question. There is one question. They are saying the far point of a myopic person is 80 centimeter. This is a question from NCERT. The far point of a myopic person is 80 centimeter, means up to 80 centimeter, this person is able to see the object. If I am saying 82 centimeter, up to 82 centimeter, he or she cannot see. But up to 80 centimeter, he can or she can see the objects clearly. So this is a far point of a myopic person given 80 centimeter. There is an object in front of the eye. Okay, so so they are saying the far point of a myopic person is 80 centimeter in front of the eye. What is the nature and the power of the lens? What is the nature and the power of the lens required to correct this defect? First thing here, see, this is written as myopic. This is written as myopic. So this will give you the idea this person have the myopia. So for myopia, what we take the object distance infinity, and what we take the image distance, what we take the image distance, far point of the object, far point of the person. 80 centi. What will be the value, Martin, for the image?
80 centimeters.
No, minus 80 centimeter. Why minus 80 centimeters? See here. You can see here. This is the length, na? This is the length, and image is formed on the left side of the length, na? On the left side, and I have told
Yes.
you on the left side we will take the negative distances in
Yeah.
sign convention. That is why I am taking minus 80. So these points you should remember.
Okay.
Now we can calculate the focal length. What is the formula? 1 upon V minus 1 upon U is equal to 1 upon F. Okay, I am giving you the hint. 1 upon infinity is equal to 0. So all of you try this question by yourself. Hamna and Martin and Abdullah. All of you. This is a very easy question. One upon infinity is equal to 0. Better try to solve the question by yourself, because in examination you have to solve the question. So what is V? 1 by minus 180. What is U? 1 by infinity is equal to 1 by F. I have told you this term will become 0. Okay. So you will have this is 0 na. So you will have minus 1 by, this is not 18, this is 80. This is 80 na. So this will become minus 1 by 80, and this is equal to 1 by F. So focal length is equal to minus 80 centimeter. Focal length is equal to minus 80 centimeter. Okay, focal length you will get, and I have told you negative focal length of convex lens. So from here also we can get. So what is the power? Power is equal to 1 upon focal length, and this focal length should be in meters. But this focal length we have calculated is given in centimeter. So we will divide it by 100. So basically what we will get? What we will get? We will get, this is, yeah, this is 0.8 you can say. Okay. So here will be 0.8 minus 0.8 minus 0.8 meters we will get. Now put the value in this power formula. Put the value. P is equal to 1 by F. P is equal to 1 upon minus 0.8. So basically what will be the power? 10 by 8. 10 by 8 means 5 by 4 means 2.5 by 2 means 1.25. 1.25 diopter. Oh, sorry.
So how is it 8 from 0.8?
Sorry. Actually, it will be na. It will be just a minute. Calculate it. When you will, it will be 5 by 4 na.
So
But
how is it from 0.8 it turns to 8?
just a minute. How this? See, this is 1. This is focal length is 0.8 na minus. When you will remove the point, you will multiply here with 10. This is math.
Okay, yeah.
So this will be 10 by minus 8. Okay. So now you will cancel it out. It will become 5 by minus 4. Okay. So when you will just do it division by 4, this with 4 ones are 4, 4 twos are 8, 4 fives are 20, and this is diopter minus 1.25 diopter. 1.25 diopter. Got it?
Yes, sir.
Okay, so just wait, don't note up now. We will discuss first hypermetropia, then you will note. So see, what is hypermetropia? There is another defect, another eye defect. I have told you three type of defect I will discuss. The second type of defect, hypermetropia. You can say long sightedness or far sightedness. Okay. So basically, this person is not able to read the book. Why? See, this man is having a eye defect called hypermetropia. He cannot read a book clearly by holding it at a normal distance of 25 centimeter. He has to hold the book at a much larger distance than the arm length. Means suppose this is a mobile phone and this is something at a distance of 20 or 25 centimeter. So at this distance, na, I will not able to see the object if I will have the hypermetropia. Uh, Hypermetropia means that nearby object the person is not able to see properly, but the distant object he or she can see properly. Okay, so basically hypermetropia. So I am removing this diagram. Hypermetropia. It is a defect of vision due to which it is defect of vision due to which a person cannot see nearby object. Nearby object. Like this book is nearby to this person, so he is not able to read the text properly. Okay, though he or she can see distant objects clearly. In this case, what happens? The near point of the person, basically what is the normal near point? 25 25 centimeter. So basically the near point of the person becomes more than 25 centimeter. So the near point of hypermetropic of a hypermetropic eye is more than 25 centimeter, is more than 25 centimeter. Okay, more than 25 centimeter. What are the causes? Number one, earlier we have discussed the myopia, and myopia is due to the high converging power of the lens, but this is opposite. This is due to the low converging power of the eye lens. Due to low converging power low converging power of eye lens. Second cause, there in myopia, what was the another cause? The eye wall becomes large. The eye wall becomes large. But here the cause is eye wall becomes small. eye length, or you can say eyeball, not eye length, becomes too small. Now see here, focus on this image. This is a eyeball. This is the eyeball, and this eye have the hypermetropia. Hypermetropia means nearby object this eye is not able to see clearly. Okay, so uh, in this case, if the object is at 25 centimeter, okay, for example, this is the mobile phone. For example, this is the object. This is the object. Okay, this is the object, and these are my eyes. And suppose I have suppose I have hypermetropia, means uh, if the object is at 25 centimeter, I will not able to see the object. Why? Because I have hypermetropia, and hypermetropia means the far point of my eye will be more than 25 centimeters. So this is the object, and these are my eyes, and I have hypermetropia, suppose, and now I am not able to see this object. Why? Because at this time, what is happening now? The image is forming behind the retina. Image is forming behind the retina. If the object is at the 25 centimeter from my eye, then the image will form behind the retina, and I will not able to see this object clearly. So you can see in this diagram. See, this is the object. This is the object at 25 centimeter from eye. This is your eye, not your eye. This is an eye having the hypermetropia. Okay, so 25 centimeter object image will be forming behind the retina. For proper image vision, the image should form on retina, not behind the retina, not in front of the retina. So if the object for a hypermetropic eye is at 25 centimeter, then the image will form behind the retina, and he or she will not able to get the image properly. Why? Because at retina there are light sensitive cell, rods and cones. Due to that, now we are able to get the image processing. Okay, so here the image is forming behind the retina, so there will be no processing. So that is why the person is not able to see the image clearly. Okay, so as you can see here, 13.8 shows that the eye having a defect eye hypermetropia. In this case, these are the diverging rays from the nearby object. What I have told you, nearby object gives the diverging rays. Nearby object, I have told you in the last to last class, nearby, from the nearby object we get the diverging rays, and from the distant object we get the parallel rays. And 25 centimeter is the nearby distance now, so we will get a diverging rays. So this is the eye lens. So this eye lens is converging these rays, but the final conversion is behind the retina. Final conversion is behind the retina. So that is why this person or this eye will not able to see this object at this position. Now but just a minute, okay, all of you just wait a minute. Okay, so now again I am taking example. This is the object, and suppose my eye have the hypermetropia. Eyes have hypermetropia, and This is the object. Now this object is at the far point. My eye's far point, and my eye's far point will be greater than 25 centimeter, na? Greater than 25 centimeter. Then
Yes.
now I can see this object clearly. If this will be at far point of my eye, and my eye have hypermetropia, remember this point. Now I can see this object clearly. Why? Because this time the image is formed at retina. Okay, so you can see in this figure, if the object is the near point of the eye, okay, oh, sorry, I have said far point, this is near point. Okay, so if the object will be at the near point, then the image will, and then the image is forming at retina. That is why this eye is able to see this object. Okay, and this near point of the eye is, sorry, I have told you far point, but this will be the near point. So near point for the hypermetropic eye becomes more than 25 centimeter. So if you are placing the object, if you want to, if this eye want to see the object which is at near point of the or hypermetropic eye, then the image will be formed on retina, and this eye will able to see the object clearly, and this thing will be used to correct the myopia, hypermetropia. Okay, this thing will be used to correct the hypermetropia. Somehow if our object will be here, somehow if our object will be here, then this hypermetropic eye will able to see the object clearly. Somehow we have to take the object at near point. Then what, how we will do this thing, how we will do this thing? Okay, first note down, then I will tell you how we will do this thing. Okay, so note down, all of you. Both of these formulas are very, very important. Write down Hamna and Martin.
Okay, sir.
Hamna, have you got the hypermetropia? Martin, have you got?
Yes, sir.
Basically, in hypermetropia, what happens? The near point of the person becomes greater than 25 centimeter. Write down fast, Hamna and Martin.
Done, sir.
Hamna, completed? Okay.
Yes.
Okay, beta. So write down this. Saad. Hello, Saad.
Yes, sir.
How are you?
I'm fine, sir. How are you, sir?
I'm good. Okay, so we will talk at the end of the class. Okay.
Okay, sir. Sure.
Done. Hamna and Martin completed.
Sir, just one doubt. How is 1 upon infinity 0 and not defined? Because 1 upon infinity is usually not defined.
Hmm.
Why are we taking 1 upon infinity as 0?
Beta, that is 1 by 0 not defined. 1 by 0 is not defined. 1 by infinity is 0. That is something different you are telling. One we say indeterminate form when 1 by 0 is there. Got it?
Yes, sir.
We say 1 by 0 is not defined. Done?
Yeah, done, sir.
Hamna completed?
Yes, sir.
Okay, so write down the this. Basically, what is your name? Saad. There are 7 indeterminate forms. Okay, there are 7 different indeterminate forms. When you will go to 11th class, then you will know. Okay, there are 7 indeterminate forms. 1 by 0, infinity by infinity, 1 to the power infinity. Okay.
Okay, sir.
0 by 0 is also an indeterminate form. So I am not going in that. That is beyond your syllabus. Write down fast.
Yeah, done, sir.
Okay, so write down this. Removing this diagram. Completed. Scroll down. Martin and Hamna.
You can scroll down, sir.
Saad, have you completed this chapter? Okay, so draw this figure. Draw these two diagrams, and after this we will discuss the correction of hypermetropia. So here, if you are placing, if the object is at the near point of hypermetropic eye, near point of hypermetropic eye, then the object will be visible. Why? Because the image is forming at retina. Why we are able to see the image when the image is formed at retina? Because retina have light sensitive cell, rods and cones. I have told you. Okay.
Okay, sir.
Saad, you are also writing?
Yes, sir.
Okay. So Saad, do you have any doubt in this?
No, sir. I actually completed this chapter and I also revised it like many times. So it's like really easy for me.
Okay. Martin, completed.
No, sir.
Hmm?
Going to complete, sir.
Okay.
Yeah, done, sir.
Done. Hamna? Okay. Now, basically, remember this point once again. If somehow the object will be here at the near point of the hypermetropic eye, then the hypermetropic eye can get the image of that object. So see how we will do this. Basically, we will place a convex lens this time, and that convex lens will produces the image of the object, actual object at the near point. Okay, at the far point. Okay, so see here. Basically, this is your diagram. This is your eye. This is the eyeball. This is the eye lens. We know. Okay, so this is the object this eye want to see. This is the object this eye want to see. Suppose this is the person, and this person is present at the near point of this eye. Okay, near point of this eye. Now, if this object will be near point of this eye, if there is no convex lens in between, then what will happen? The image will form behind the retina and this eye will not able to see the object. But here what is happening? Here is the object at the near point that this eye want to see. Now you have placed a convex lens. Convex lens is also known as a converging lens, basically. Okay, so I have told you object is a source of light, directly or indirectly. Object is a source of light. So from this object, there will be light rays. Light rays will be like this. And this is a nearby object, and I have told you nearby objects gives the diverging light rays. So there will be diverging light rays. And this is a lens you have placed. And this lens is a convex lens. So what happened? These are the rays. Okay, these are the rays. And there will be the refraction from this lens, and due to the refraction the image of this object, a virtual image of this object will be formed here at this point. And what is this point? This is the actual near point of the of the hypermetropic eye. means up to this distance this eye is able to see the object. Okay, so basically now initially the object is here, actual object is here, but the image of that object formed by this lens here. So for this eye, or you can say for this eye lens, this will behave the object, this image formed by this lens here, that is the that is at the near point of the eye, will behave as the object. Basically this is the virtual image formed by this lens at the, what is this point, this point is the near point of hypermetropic eye. So I have told you, if you are placing an object at near point of hypermetropic eye, then image will formed on retina, image will formed on retina. Okay, so for this lens, now this will be the object. So according to this object, now the image will be formed on the retina, and this eye is able to see this object. This will be the actual object. Okay, actual object. Calculation of power. Calculation of power of convex lens. We have used convex lens to correct hypermetropia. Calculation of power of convex lens to correct hypermetropia. Okay, in this case, see this picture. What will be the image, what will be the object distance, what will be the object distance, this will be the object distance now. In this image, basically for the hypermetropic eye, this will be the image formed by this lens, this will be the image formed by this lens. Okay, and this is the object, okay. So basically the object distance in this case, you will take normal near point. Okay, the object distance you will take normal near point. Okay, so object distance you will take normal near point. What is the normal near point? 25 centimeter. And in front of the eye, then you will take this as minus 25 centimeter. Okay, so image distance you will take the near point of hypermetropic eye, near point of hypermetropic eye. So this is the near point of the hypermetropic eye, and finally the image is formed here. Okay, so that is why we are taking the image distance this. Okay, One question. They are saying the near point of the hypermetropic eye is 1 meter. See here it is written that hypermetropic. They are saying near point of the hypermetropic eye is 1 meter. What is the nature and the power of the lens required to correct this defect? First of all, we know for correction of the hypermetropia or hypermetropic eye, convex lens will be used. Convex lens will be used. And power of the lens we can calculate with the help of focal length. Okay. So object distance what we take? Minus 25 centimeter. Image distance we take the near point of the hypermetropic eye, that is 1 meter. This will be also negative. This will be also negative, okay? Because this will be also in front of the lens. Okay, so 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter. So this will be minus 100 centimeter. Focal length we can find 1 upon V minus 1 upon U is equal to 1 upon F. Okay, so 1 upon minus 100 minus of 1 upon minus 25 is equal to 1 by
You
F.
have to convert the 25 into meter.
Beta, I have just converted this 1 meter into centimeter because in 1 meter there are 100 centimeter.
Oh, okay.
Okay, in 1 meter there are 100 centimeter. Now we can solve this. This will become 1 by 25 minus 1 by 100 is equal to 1 by F. So this will, you can take the LCM 100. This will become 4. This will become 1. This will become 1 by F. From here what you will get? You will get this is 100 by 3. Focal length what you will get? 100 by 3. 100 by 3 is 33.3 centimeter you will get. Now this focal length is in centimeter. If you want to calculate the power, what is the formula? 1 upon F, and this F should be in meter. Now you will convert this 33.3 centimeter into meter. Okay, so how you will convert? This is 33.3 and you will divide it by 100. Okay, so you will get 0.333. Now put the value. This is P is equal to 1 upon 0.333, and finally you will, when you will solve it, so you will get here you will get this is 30 divided by this, and you will get 3, approximately you will get 3 diopter. Okay, and here this is plus 3 diopter, and focal length also in positive. Why? Because converging lens is used here. Converging lens is used here. Okay, write down fast.
Okay.
Hmm? Hamna and Martin, write down.
Next slide, sir.
Hmm?
So next I completed.
You have completed. Okay. Hamna completed. Okay. Beta, minus sign I am taking because object and image both are in front of the mirror. I have told you the sign convention.
Yeah, sir.
Completed, Martin?
Yes, sir.
Okay, Martin. So we will meet in the next class. Until then, revise your notes properly. Okay.
Yes, sir.
Okay, fine.
Thank you, sir.
Okay. Okay, Hamna, you can also leave. And
Okay,
Saad.
teacher.
Yeah, okay. Saad. So, Saad, you have completed this chapter. Hello, Saad. Beta, are you getting my voice? Hello, Saad. Hello, Saad.